At this point, you can imagine this water as one particle or one molecule, you know what I mean? Or one block.
Mm-hmm.
So if there's a block or there's a molecule, and there's an atom, you fall from here to here. How far does it go? This is something we learned from mathematics, right? And you can also imagine that sometimes whether people see whether it's see if you throw a block like this in horizontal, and then you have water shooting out from here to here. You can imagine the experiment tells us it's the same. Oh, it's the same how far here, it's the same how far here. And also it's the same time, right? So kind of making sense the simulation, right? It's just like the block. Projectile basically, right? Is it?
Oh yeah, it's kind of like projectile.
And also because if there is not projectile, there's well, we can't really do this. I don't think we can do this if it's not projectile. So if it is projectile, how do you do?
Projectile you do. Well, how far is point X from that? We need to know how much force, right? To push
well, in projectile, what I mean is I know the horizontal is v, which means constant velocity, right? And this time here it's a g acceleration in here, right? Uniform acceleration. And then v is basically what I find. V0 is square root 2gh, right? I know, right?
Yeah.
So all I need is finding the t, right? V0 times t is gonna be how far, you know, it's gonna be answer B, right?
Yeah.
How far is point X from the edge of the tank, which is this, right? Horizontal displacement. So this is basically dot X here. So what is the t now? The question is.
T.
What is the time? How long does it take?
T. If it was that it's T, you'd have to.
Yeah, t, I can't really find it horizontally, but I can find it vertically because it's the same t, right? Remember?
Oh, yeah.
Because at the same time you reach it here is at the same time you reach here. So that's why it's the two component of this one motion, right? This curve motion is divided into one motion vertically and one motion horizontally. So can you find the time t in vertical direction? Vertically, I know it's g acceleration in here.
Yeah.
So, and also the initial velocity vertically is 0, right? Because you're shooting out horizontally. So that's 0. That's g acceleration in here. And that's the height. What's the height in vertically? It's basically, what's this height?
Oh, it's d minus h.
Yes, it's d minus h. So can you find time using the big 5, I guess? This is accumulate. This is not accumulate. Uniform acceleration. Yes. I can totally use big five.
BG times H. D minus H.
Yeah, D minus H.
D minus H. That equals L. D minus H is the
vertical displacement. Okay.
yeah.
And that should be because I can use V. I have G acceleration. I also have initial velocity. So a formula that contains initial velocity, contains the time, contains the velocity. I use this one, right? Because this one is 0, right? So I kind of just 0 times t, which means 1/2 gt squared, right? Does that make sense? So I can find t, which is 2 times d minus h over g and square root that, right? Does that make sense? So I can use this t and time the v0 horizontally. I should probably mention this is v0y here. And so 2gh times square root 2 d minus h and wait, oh, g here. So square root g and square root g can be simplified, right?
Yeah.
And 2 is out, right? So it's 2 square root of h times d minus h, right? Is it?
Yeah.
Yeah. Well, let me see, what is this thing actually? Oh, tank. There's the tank. Sure. Bring the tank of water. So this is B, right? Kinematics. And what B? This one. This is the cherry. And C. Assume that a second small hole is pictured in the side. Oh, second one. Side of tank. The distance 1 over h over 1 directly above the hole shown in the figure. Okay. The distance. Okay, so which is wait, what is it? So this is the second point, right? Is it? So if the stream of water emerging from the second hole also lands on X, wow. Talking about coincidence. Find H in terms of D. That's nice. Same location as point X. And he won't find H in terms of D. Oh, H and D have a relationship.
Yeah. Find H in terms of D. What?
Is the situation making sense a little?
Yeah.
So, do you feel it's a little similar?
Yeah.
Not only this part is the same, Also, they look similar, right? And something like
Mhm.
this shooting out, and something like this shooting out. When I say they are similar, which means if they are really similar, which means if I forget about this, if I saying this is block, if I forget about this, I can totally use what I learned in B. Is that making sense?
Mm-hmm.
So it just this time, last time is H. This time is basically 1 over 2H, right? So last time's formula is 2 square root, is it H times? H times D minus H, right?
Mm-hmm. Mm-hmm.
So this time, it's gonna be, well, your H is becoming 1 over 2H, right? And your H, well, new H is becoming 1 over 2H. Does that make sense?
Yeah.
So this should be my distance delta x for like a 0.2, right? Does that make sense?
Mm-hmm.
But they said it's the same thing as the last time. This time, this delta x is the 0.1. How far horizontally? They said they should be the same. So this two should be equal with each other, right? Is it?
Mm-hmm.
So that is the equation that we can use to solve the relation between D and H, right? So 2 and 2 simplified, square root simplified. So basically it's H, H times D minus H equals to 1 over 2H times D minus 1 over 2H. Does that make sense?
Mm-hmm.
So H and H simplified. So time 2. So here's a 2, there's a 1. So now it's 2D minus H equals to D minus 1 over 2H. Does that make sense?
Mm-hmm.
So I'm going to expand that as a 2D. That's a D. So it's a D in here. So that's a negative 2H. Moving that is 2H, positive 2H minus 1 over 2H, which is 3 over 2H, right?
Mm-hmm.
Yep. So H is 2 over 3D then, right? That is the answer for C, right? You want an H in terms of D. Does that make sense?
Yeah.
Yeah. This is more like a set up an equation and solve something, right? The equation is that distance equal to that distance. I mean horizontal distance. Both of them are the same. Does that make sense?
Yeah.
This someone asked saying, does this 0.1 gonna influence that 0.2? Well, that is something we haven't learned, right? Don't think about that. And also it's not.
Mm-hmm.
Does that make sense? Because we're thinking about the moment it's not changing. Does that make sense? So if this decrease, that's another story, right? Does that make sense? When I think about the moment in the beginning, right? Does that make sense?
Mm-hmm.
So the level is still that high. Yeah, so they don't influence each other. And also we can try, right? Have you seen that before? Like you puncture a hole in here and puncture a hole, and the water actually it is like that, right? You can try it. It looks like that. Does that make sense? The horizontal distance. I mean, could be the thing.
Uh-huh.
As long that H and D have a relationship. It's basically what the relation that we use. Here, D. For this part, do not assume that the speed with which the water level in the tank drops is negligible. And derive an expression for the speed of the H below the surface. Write the answer in terms of R or HG. Well, if not, this time V1 is not 0 anymore, right?
Mm-hmm.
Last time we assumed V1 is 0, so that's why we use that square root GH thing. Okay.
Mm-hmm.
Well, it's get complicated, so I guess we only have that big equation. It doesn't seem that there's a way to simplify it, so I'm gonna write the big one anyway. P1 is rho G y1 plus 1 over 2 rho v1 squared equals P2 rho G y2 plus 1 over 2 rho v2 squared. Okay, what do we know? V1, P1 and P2, isn't that all like atmosphere pressure? Atmosphere pressure? Air pressure, right?
Yeah.
That doesn't change anyway, right? Does that make sense?
Yeah.
And what is our reference level? Probably our horizontal level is good enough, right? This one is the reference level, maybe, right? Seems reasonable. So then D Y1 is then D, right? Y1 is D. And Y2 is D minus H, right?
Yeah.
Here's D minus H. This V1 can't be considered 0. There is something we haven't used. Let me show you the whole picture. There's a readers here we haven't used. There are readers here we haven't used. It's like a 101 thing, remember? Remember that saying 10 to 1 and 1 and 1 to 1? Yeah. So I can use the area, so because I have continuity equation that I can use, right? Does that make sense? So I can write A1 times V1 equals to A2 times V2, right? Anything else?
Yeah.
So now I can say V1. They want to use R. Let's use V1. If it's V1, it's A2 over A1, right? Times V2, right? Well, I don't want to substitute this to R yet because that is a little more complicated. Eventually, I can substitute that, right? Just leave it there. So now this, well, this is a little messy. Let me write this again. Rho GD plus 1 over 2 rho, here's A2 over A1 V2, right? Square equals to rho G D minus H plus 1 over 2 rho V2 squared, right?
Yeah.
You see, rho GD must cancel out, right?
Yeah. Oh, gee.
Mm,
Oh, yeah. OGT.
I have a rho g on both sides anyway, right?
Yeah. Yeah, wait.
And I have 1/2, there's 1/2 rho, v squared. Also, there is a v squared, v2 squared anyway, right? Correct, 1/2 rho, v2 squared, and then times a2 over a1, this should be squared, minus 1, right?
Yeah.
And equals to, if I move it, if I expand that, rho gd is out. So it's negative rho gh, right?
Mm-hmm.
Okay, I think I am getting somewhere. Rho and rho simplified. So that'll be 2gh. Since this is negative, so I'm going to change the order in here. It's just rho 2gh over 1 minus a2 over a1 square, right? Does that make sense? If we want a v2, because this v2 square, I have square root that, right? Does that make sense? Let's see what's a2 over a1 now. It's probably the time. There's nothing else we can do right now.
A2 over A1.
a2 over a1. A2 is here, right? Which means R over R, because there's pi R square and pi R square, right? Pi is out, and you have square that. Basically, it's R fourth power to R fourth power, right? Let's see, does it satisfy? Yes. So now there's only G, H, R, R. Yes, now it's okay, right? Square root 2GH over 1 minus R over R to the fourth power, right? Did it make sense? So that's probably D, right?
Yeah.
We are using the, well, the most complicated equation in this chapter, and if nothing else that we can do, we use that, right? And we find P1, P2 both the same atmosphere pressure. And then everything else is substitution. Don't forget the continuity equation, right? It's also a simultaneous equation or system. Is 2 okay?
Yeah.
More like a substitution and math calculation. See 3. The figure below shows a pipe fitted with the VU tube with density F rho F flows at a constant flow rate. The viscosity through the pipe, which constricts from cross-section area A1 at point 1 to smaller cross-section A2. That proportion of both sides of this contains the same fluid that's floating through the pipe. So the lower portion is filled with fluid density V, rho V, which is greater than rho F. At a point 1 in the pipe, the pressure is rho P1 and the V1, P2, V2. All the fluid within the tube is stationary. Let's see the first one. What's the PX at point X? Right answer in this. Okay. Go to the PX. They mentioned pressure and also about pressure. They have a P1, right? They said at 0.1 in the pipe, the pressure is P1.
Mm-hmm.
So here is a P1. So that pressure also is going to expand to here, right?
Yeah.
So I guess I have to use P1 plus that she's having a point X. What else did it tell us? Oh wait, it's at this point. At this point, it's at point one. At point one in the pipe, the pressure is P1. So here's P1, but the it's the fluid or something. Yeah, but what's downstairs also going to give a pressure, right?
Mm-hmm.
So two parts of pressure. One is P1, the other is basically rho G, I think it's H1, right?
Mm-hmm.
When I say rho, let's see which rho that we should use. Which rho should we use? In pipe 1. We have rho V, probably not the case. We also have I think we have rho F. Yeah. And here's the rho F, right? Also they mentioned in here. So there's rho F in here, right? Does that make sense?
Mm-hmm.
Although it seems like there's only fluid in here. But there's there's also in here, right?
Yeah.
And at this point, only H matters or something from here matters. Does that make sense? If I write it like this?
Mm-hmm.
Answer PX, right? How about PY? It's similar, right? At point Y, what's the pressure here? Hydrostatic.
Pressure P1.
I think it's the same thing, right?
Yeah.
Unless there's a little bit something else adding, right? So there's 3 parts of that. One is something you give in here, which is P1. Is it P1? Wait, it's P2 because they mentioned. Let me read a little more. Oh yes, he said 0.2 has a P2. So here's the pressure in here, but here's also the pressure from here, which is the rho GH2, right? When I say rho, it's the rho F, right?
Mm-hmm.
So here's P2 plus rho F times GH2, right? But there's also a little pressure from this liquid. So what's the liquid pressure in here?
Um,
The liquid. Well, if I'm talking about that, then forget about anything else. Nothing is in here. Only, a little liquid in here. So that's another rho GH, right?
Mm-hmm.
But you just have to use this HSD, right?
Mm-hmm.
Rho GD, and then rho is the liquid. I think it's a P. Rho. Here's another rho. Where's the other rho? Oh, here's rho V. I think they mentioned it in the question too. Oh, here it is, rho V. So I'm going to use rho V G D, right?
Mm-hmm.
There it is. So this is a PX, this is a PY, right? PX, this is a PY. Also the question 1 and 2. Does that make sense?
Mm-hmm.
It's just kind of have different layers, right? It's kind of like a, this pressure thing is kind of like a building, right? This building gives a little pressure, right? And this part of the building gives a little pressure, and this part of the building gives a little pressure. Does that make sense? I mean, kind of like that. See, write down the results. Point 1, point 2, and solve for P1 minus. Oh, that is the big equation again. Does P1 and P2 same level? They have the same Y, right?
Mm-hmm.
Does that mean it?
Yeah.
So, which means if we do it, I don't have to write down that 1/2 rho Y, the rho GY thing. I don't have to write, right? I just have to write P1 plus 1/2 rho. Oh, they have different rho. I have to be careful. Rho F. So this is the liquid in here. It's rho F, right? It's not this kind of liquid. Rho F V1 square and P2 rho F V2 square, right?
Mm-hmm.
I can, well, definitely can find a P1 over P2, but well, is V1 V2 something they provide already?
No. Wait. No.
Let's read it again. See what is something they provide. V2 and V1. Well, just remember this one always combined with continuity equation, right? I'm going to write continuity equation anyway. A1, V1, A2, V2, right?
Mm-hmm.
They have to give the A1 and A2. Cool. Why can't I just use V1 and V2? Write down the results. That's fine. Not for P1 over P2. I think the same thing as we did before. We probably use V1 and V2 as one of them, and it's something that we know, right?
Mm-hmm.
Let's see. The upper portion, the lower at point 1, at point 2. So I'm going to put in there. So because A1 and A2 is definitely something we know. So we're going to P1 minus P2, because this is kind of popular this way. Rho F V2 squared minus, remember what we did last time? It must be like if it is V2, if it's V2, I'm gonna change V1 into A2 over A1 times V2, right?
Mm-hmm.
That means? So
Yeah.
this one is gonna be 1 minus that A2 over A1 square, right? And I get the common factor 1 over 2 rho F times V2 squared. That make sense?
Mm-hmm.
Yeah, I think that pretty much answers this question, right?
Yeah.
Also, it's something that we just did in the last previous question. Yeah, here. Let's say D then. Is C okay? Is C making sense now?
Yeah.
I can just leave it there. Of course, there's a little dilemma in here. He didn't really specific say V2 and V1 is which one is something known, which one is something unknown. Otherwise, I can just use this one to find it, right?
Mm-hmm.
Yeah, but it's always like that. So we kind of use this like a ratio thing. Normally, only one velocity is given, right?
Yeah.
Yeah, let's do D. Since Px equals to Py, set expression we derive it in part A and B equal to each other, and use this equation to find P1. Px minus Py. Ah. Wait, let me see. Why Px equals to Py? Px and Py. This is something I probably haven't told you. I don't know whether you learned it before. This is called U-tube, right?
Yeah.
Do they have some property that we like? Do you know? Have you learned this before? No?
No.
It's kind of like this. Normally, for example, if I just pour in the water, it would just, go around a little bit, right? Eventually,
Yeah.
when it reaches to a level, normally it should be just same level, right? Does that make sense?
Mm-hmm.
I mean, this is a normal case. Does that make sense? I think they use someone for the wine or something. Oh, you probably saw it somewhere. So anyway, this is making sense, right? But you understand sometimes the pressure here is not the same, so something else could also happen. It's like this level here, but this is the level here, which means the pressure in here and the pressure here are different, right? But they can also be static. Does that make sense?
Mm-hmm.
Could it be this or could it be this? But even though, as long as it's static, so you have to balance the force, right? It's kind of the left have a force and the right have that force, and you kind of have to balance that, right? Does that make sense?
Mm-hmm.
So it's kind of like this side of the water and this side of the liquid is going to be balancing each other, right? So which means what we test is this. This pressure and this pressure, as long as they're the same level, as long as they're static, so it's always going to be the same. That's a property for U-tube. Does that make sense?
Mm-hmm.
I don't have to know the atmosphere in in here, in here, and in here. I just know as long as it's static, as long as the U-tube, so it also it makes sense in the balancing force, right?
Mm-hmm.
So basically, the force in here, all the force in here, and all the force in here should definitely balance. Otherwise, it's not going to be static, right?
Mm-hmm.
Does that make sense? Otherwise, they will cause the flow of the liquid. As long as it's static, so if you have the same level, then your pressure should be the same. Does that make sense?
Mm-hmm.
Let me say this again. As long as it's a static U-tube, this, of course, is balanced. If it's not balanced like this, but the same levels pressure is always the same. Is that okay?
Mm-hmm.
Yeah. So that's why they said it, and you should keep that in mind. It's also something. And so you should. So that's why they since px equals to py. Is that okay? Because it's a U-tube, we consider it as a known fact. Is that okay? Does that make sense? So that's why they say px equals to py. So we should use this because we have px. Do you remember what's px?
Px.
In A is p1 plus that rho gh1 thing, right?
Yeah.
And p2 should be the same. I mean, wait, py, p2 plus rho gh2 plus rho gd, right? Remember? I should find, this is F liquid, this is V liquid, right? Does that make sense?
Mm-hmm.
They said use this equal with each other. I think we use this equation to find P1. Oh, just P1 minus P2, right?
Mm-hmm.
Put this in here, right?
Yeah.
Wait, H2 minus H1 is a negative D, right? Yeah, H2 minus H1. H2 minus H1. Yeah, it's a negative D. Eventually, it's rho FG negative D plus rho VGD, right? I can get the GD out, and basically it's rho V minus rho F, right?
Mm-hmm.
Does that make sense? Yeah, that'll be the answer for D, right? Does that make sense?
Yeah.
So I want to mention again, the UF, PF equals PY is something we have to remember. It does happen in the test. But also it happens a lot in the future, you will find it. Is D okay? Because of this, you have to keep in mind. As long as the U2, that will happen. They don't have to be the same level, but the same level pressure will be the same. So that's why you being static. E, derive an expression for the flow speed V2 and the flow speed F in term, wait. Oh, in term of A1, A2, D, all this. So the V2 and F are proportional to D. Yeah, this is basically when you find V2, right?
Yeah.
In this kind of situation, sometimes it's always related to the previous question. Previous question, we just find P1 or minus P2, right? I think we find P1 minus P2 in C2, right? Is it? This have a P1 minus P2, and I think this contains with V2. And this also is P1 minus P2. They should be equal with each other, right? There's no new information, so CD should be working at the same time, right?
Mm-hmm.
Does that make sense? So I can let the result of C equal to the result of D. Can I? So that one we just wrote for D. It's rho, I think it's GD, and then rho V minus rho F, right? This is P1 minus P2 in that. And then in C, is that 1 over 2 rho V, is V1 square, V2 square. And this is rho F. And that is, I think it's 1 minus A2 over A1 square thing, right? Remember? So they should be equal with each other, right? Because they want to find V2. And rho can be, oh, not exactly, rho and rho can be out. Well, at least G can, well, they don't all have G, huh? Sadly. I guess there's no easy way out for this. There's nothing we can simplify, right? Can we? No. So you can you find V2 according to this? Maybe you should write something.
Wait.
Just find V2 anyway, I guess.
In terms of V2 squared, I have to multiply this out by 2 and then divide by 1 minus AC over A2 over A1 squared. And then divide by P rho F. Right, and then that'd be GD2. To GD.
Yeah.
Divided by 1 minus. That rho F. Rho F. And square root of this. That's V2. That's V2. That's
2
V2.
GDPF rho V minus rho F over rho F and 1 minus, yes, this is V2. Sure. And the flow rate, do you still remember flow rate? We didn't mention that a lot.
Flow rate, I don't think so.
AV. Because flow rate is the same, and a flow rate is A times V, that's why we have A1, V1. This is flow rate. So they're both equals to flow rate. Does that make sense? Well, the material can't be disappearing, so flow rate making sense, right?
Mm-hmm.
So which means for this one, I can just use A2 times V2 float. Right? Because A2, I definitely know. A V2, I just what's you find in this one, right?
Mm-hmm.
Does that make sense?
Mm-hmm. Yeah.
Basically A2 times whatever what you just wrote, right? This big complicated thing, right? Does that make sense? So now I have the expression for F. And also in the end, they want to show us V2 and F are proportional to square root D.
Yeah.
If you're really proportional,
Proportional square root of D. Well, F is flow rate equals E
so let's
times
prove V2 is proportional to square root D first. Because your big expression is this is V2, right? Anyway, right?
mhm.
This is V2 and this is your right here. Square root D is here. Can you see that?
Yeah.
So basically, I can just prove V2 over square root D is that, that big square thing, right? What's, get rid of D, right? Because everything in there so that's why it's proportional. Does that make sense? That's why V2 and square root D are proportional. Does that make sense?
Mm-hmm.
Yeah, same thing as I can prove that F over square root D, because your expression is A2 times V2. Of course, V2 already proportional, then F is proportional. If we have to do as the original form, F over square root D is basically also that big thing, right? There's another A2 there, nothing else, right?
Mm-hmm.
So both, this one is a constant, this one is also constant, all the number provided, all the data provided, right? So that's why both of them are proportional to square root D. Does that make sense?
Mm-hmm. Yeah.
Does it make sense?
Mm-hmm.
Okay. And I remember the anxious shit about one of this part is there's slightly mistake. If you look at it, you can know because the proving process sometimes probably typo here. So is E okay?
Yeah.
Yeah. Basically, this is between V2 over square root D is a constant, and F over square root D is constant. And you can see that square root D happens in here. There's a D and there's a square root out. There's square root. That's something we're gonna learn in the future. Now let's does that make sense now?
Mm-hmm.
Well, we basically covered everything. But we learned something new in here. Px over Py is the same. Can you describe that a little bit? Px over Py. When Px equals Py.
Px equals Py. Oh, Px is Px equals py, because the pressure is like the same, right?
Yes. Also because you have to force it the same. Otherwise, this have to move. Why you are static, right?
Mm-hmm.
So that's why in any YouTube, as long as static, of course, if the same level, we can know that for sure a lot. As long as static, the same level of pressure is always going to be the same. As long as the same horizontal level. So we have px over py. Px equals to py. Is that okay?
Yeah.
And we use the big binary equation and the continuity equation a lot, right? They can be put as a simultaneous equation, right?
Mm-hmm.
Okay, and then the homework for today, well, I've got to redo everything.
Okay.
And also, we did the practice test number 2, right?
Yeah.
Oh, not this one. That one. You can just do the rest of them.
Okay.
Yeah, and there's question you can mark in. Yeah.
Okay.
Of course, right now, if you have time, you can always just do it because there's practice tests there. Anyway. After the
Okay.
practice, we're gonna do the real test.
Okay.
Kind of similar anyway.
Okay.
Okay. How long do you have for homework?
I like hour and a half, 2 hours.
But yeah, that's probably redo everything that we did because it's a little messy, and also it's long calculation.
Okay.
And then yeah, do that practice test.
Okay.
Have a good day. God bless you.
Thank you.